Welcome students. In the previous class we actually discussed about what is refraction and rules of refraction and also discuss about refraction of light through a parallel glass slab and how actually what is the relation between angle of incidence and angle of emergence for a parallel glass slab. Now today we actually discuss about refraction of refraction of light through glass prism. Okay, through a prism. Now, at first we have to know what is actually prism. Okay, so the first question is what is prism? Okay, actually, a prism is a glass block. Okay, so it is a actually glass block that has a triangular cross section. Okay, that has a triangular cross section formed by three rectangular faces. Rectangular faces. That means actually prism is show in this manner. Actually, if we draw a prism, then we get this type of actually shape. Okay, so here actually this is the 3D picture of a prism. Okay, now actually we can see there are total 5 surfaces. Okay, if we named, then we get total 5 surfaces: A, B, C, D, E, and A. Okay, so in this case actually we get total 3 rectangular surface. That is, at first we get 3 rectangular surface A, D, E, B, and A, D, F, C, and B, C, E, F. Okay, actually 3 rectangular surfaces. These surfaces actually called refracting surfaces. Okay, these surfaces is called refracting surfaces, and actually two triangular surface, that is actually DEF and ABC. Okay, here actually for this prism DCFE This surface is called base, and actually particularly these two called refracting surfaces ADEB and ADFC. Okay, here actually the two refracting surfaces makes an angle that is called angle of prism. Okay, so here angle of prism, actually this angle is called angle of prism. Okay, so for actually simplification, we take and actually taken this type of surface that is actually take as prism. Okay, so here if we named, then we get this is angle of prism A, and we take this is ABC, and for this case AB and AC actually refracting surfaces, and BC is base and A is the angle of prism. Now in this case actually if a ray which is named as XY, okay, which is incident on surface AB, this is XY ray, then this ray actually is the incident ray XY. When this ray is traveling from air to, actually this medium is air to glass, then light enters from rarer to denser medium, and we already know what is the rules of refraction. Okay, so the rules is actually if we draw a perpendicular that is normal and actually AV surface, then this ray bends towards normal. That means actually light bends in this direction, that is YZ. Okay, and now YZ wants to travel from glass medium to again air medium, that means their denser to rarer medium. So in this case we draw a perpendicular on AC, and this is normal for AC surface, and light wants to travel away from normal, that means actually uh, that means YZ travels in this case, in this direction, that is ZR. Okay, so here actually in N1 or in N1, this is normal to AB surface, and N2 N3, N2 N3 is the normal to AC surface, and here if we named, then actually A angle is angle of prism, and XY incident ray, and YZ that is called actually refracted ray, and ZR that is emergent ray, and here actually this angle is I, so I angle is angle of incidence, angle of incidence, and if we name actually this angle, this is R1 and this is R2 angle, and here this angle is E angle. So R1 is the angle of refraction at the first surface, angle of refraction at the first surface, at the first surface AB, and R2 is the angle of refraction at the second surface, at the second surface AC. And here actually E angle, angle E is the angle of emergence, angle of emergence, and in N1 is the normal at point, normal if we take a point, this normal at point Y, and A to N to N3 is the normal at point Z. Okay, so this is actually the diffraction through glass prism, and for this case actually for AB surfaces we can say the deviation angle actually for AB, we can say for AB surface actually deviation angle delta 1 is equal to I1 minus R1, and if we take AC surface then we can say deviation delta 2 is equal to actually E minus, this angle is actually delta 2 is equal to E minus R2. And if we want to find out total deviation for glass prism, then we have to add these two deviation angles. That means delta is equal to delta 1 plus delta 2, and we can say that this is equal to I1 minus R1 plus E minus R2. Okay, so if we know this all angle, then we can find out the deviation angle. Okay, or in this case actually we can easily find out in practical system, we can easily find out what is the total deviation for a glass prism. Okay, now actually if we take a white light which is incident on a glass prism, then what happen? Actually we know white color is the combination of 7 colors. Okay, so when actually we take a prism again, and when white color is incident on one refracting surface, okay, that means we take actually this is a white color, we take, then this color is a combination of 7 different color. Okay, so after incident the white color on one refracting surface of this prism, then actually the speed of 7 different color is different. That means actually when white color enters from rarer to denser medium, then white color split into 7 different colors. Okay, So this is actually split into 7 different colors, because actually we all know the speed of 7 different colors for a particular medium is different. So white color split into 7 different colors. Okay, here is the colors. Okay, so in this case actually the first color is red and the last color is violet. Actually we get a 7 color spectrum. Okay, that is actually viv 0. Okay, so v I b g y o and r. Okay, v means violet, I means indigo, blue. V means actually we take this is violet, I means indigo, and B means blue, G means green, and Y means yellow, O means orange, R means red. Okay, and actually uh, this phenomena is called dispersion of white light by a prism, and this was first studied by Sir Isaac Newton. Okay, in 1666. Okay, in 1666. Okay, actually Sir Isaac Newton at first actually studied, and this phenomenon is called dispersion of white light by a glass prism, and this band of 7 colors is called spectrum. Okay, this is actually called, this 7 colors band is called spectrum. Okay, so here actually there are two refraction segment. One is at x point. Okay, when white light enters from rarer to denser medium or air to glass medium, and after that actually 7 different color is refracted at the second surfaces, that is AC. Okay, so this is the actually dispersion. Now the question is actually why does dispersion occur? Okay, actually why? Because dispersion occurs mainly because the different components of light bends differently, because of their speed is different in glass medium. So in this case actually when white light enters from air to glass medium, then 7 different colors moves with different speed through the material of the prism. Okay, so that is why we get spectrum like this visual. So in this case actually if we arrange then the 7 colors, 7 colors, then with respect to velocity we can say velocity of red is greater than velocity of violet. Okay, this is actually velocity decreasing order. Okay, the first red color is velocity maximum and velocity of violet is minimum. So in this case we can say deviation for red is minimum deviation, or we can say deviation of red less than deviation of violet color. Okay, so this is the reason behind dispersion. Now we move our one application, that is actually rainbow. This is our rainbow application of dispersion. Okay, now the question is actually what is rainbow? Okay, So in this case, actually we can say the most fascinating example of dispersion in nature is the rainbow. Okay, in generally it is visible in the sky after a spell of rain, and it is formed due to dispersion of sunlight. Okay, so in this case, actually, after a rainfall, actually there are several large number of water droplets suspended in atmosphere. Okay, so these droplets act like a teeny prism, and when sunlight passes through these prisms, teeny prism or spherical droplet, then white light split into seven different colors, and we see spectrum like this, and we called it is a rainbow. Okay, so actually this is the reason behind rainbow, that is simply dispersion of sunlight, okay, due to water droplets. So this is the end of today's class. Okay, so and also this is the end of the whole chapter, that is light. Okay, so in the next class we discuss about some exercise problem on light, and also discuss about the previous chapter, which is in your pre-annual syllabus, that is energy. Okay, so this is the end of today's class.